Here's problem 433. A rifle is aimed horizontally toward the center of a target, 0.1 kilometers away, but the bullet strikes 10 centimeters below the center. Calculate the velocity of the bullet just as it emerges from the rifle. So we have a rifle, and we shoot a bullet, and it's going to go. It's aimed towards a target, the center of a target. However, the actual trajectory of the bullet is down like this, so it's going to hit with some displacement delta y, and that is 10 centimeters, so 0.1 meters. And this displacement to the target is 0.1 kilometers, so that's 100 meters. Okay, and so we wish to use this information. Now in the y direction, what do we have going on? Well, our initial velocity is 0. Our acceleration is a positive 9.8 meters per second squared, so we assume that down is positive. Our displacement in the y direction is going to be 0.1 meters, and we don't know time, but that's what we can find. So here are 3 kinematic variables, and we can find the time to the target. So we'll say that displacement, delta y, is equal to initial velocity times time, 1/2 acceleration times time squared. And in this case, our initial velocity is 0. So time is going to equal 2 delta y over acceleration square root. And that's going to be 2 times 0.1 over 9.8 square root, and that's going to be a time to the target of 0.143 seconds. So that's our time to the target. What's happening in the x direction? In the x direction, we have displacement is equal to initial velocity in the x direction times time plus 1/2 acceleration times time squared, but our acceleration in the x direction is 0, and hence our initial velocity in the x direction, which actually happens to be the velocity out of the muzzle of the rifle, is going to be equal to displacement divided by time, and that's going to be 100 meters divided by 0.143 seconds, and that is going to be 699 meters per second. So that is the velocity in the x direction. That is the velocity out of the muzzle of the rifle, 699 meters per second.